Okay, welcome back. Like I said, this video is going to involve taking the single sample t-test or the one sample t-test idea and applying it in an SPSS situation. So this is a data set that is provided in the material for the corresponding week to these lessons, and it is from Andy Field, who is in it's a different textbook that you'll actually use when you transition to 8304. But for now, we're going to use it for this. So in this case, we have only one variable because, like we know, this is a single sample t-test. We just have one set of information that we're interested in. And if I click over on the variable view, I can get a little more detail about this variable. So I'm going to slide this over. Number of obsession-related thoughts. Okay, so let me set this up for you. Andy Field was working with, let me scroll down and see how many, 30 clients, and he was working to lessen the number of obsessive-related thoughts these clients were experiencing. They had all been diagnosed with obsessive-compulsive disorder, and he wanted to, through some interventions, try to help these patients have fewer obsessive-related thoughts. After the program was over, he wanted to assess whether or not his patients who had been diagnosed as having OCD, whether or not they were experiencing fewer obsessive-related thoughts than just the general population. So these are all adults. I'm not quite sure of the age range, but they are probably just a range of, say, 25 to 60 years old who had participated in his program. He wanted to compare those number of thoughts to the general population because his hope was that they were doing just fine as far as the number of obsessive-related thoughts, that it was more in line with the general population. So this is an interesting example because in this case, the researcher is not going to want to find statistical significance. Okay, so if the null hypothesis is saying these clients or these patients, the mean for these patients who have participated in an OCD therapy is also equal to the general population, right? So if he's worked with these patients and provided interventions with these patients, he doesn't want them to differ from the general population, right? So when we run this data, if we find no statistical significance, in this case, that's actually a preferred finding to finding out that they are still having more obsessive-related thoughts than just your undiagnosed person who we assume does not have OCD. Well, of course, we don't know that's always the case, but anyway, that's the setup for this scenario. So you enter your data such as this. This is an intervally scaled data. It's a count of the number of thoughts, and I don't have any information on how that data was collected, if it was a self-report by the clients or, well, it had to be a self-report, right? But anyway, we're not going to get into that. It is an intervally scaled data variable. So to run the test, I'm going to go to Analyze, and what do you think? Where should we go? What are we doing here? We're comparing means, right? We're going to compare means, our mean, to the population mean. And there it is, the one sample t-test. Again, I'm using that interchangeably with a single sample t-test because you'll hear it talked about both ways. So I'm going to click on that. The variable I care about, well, I kind of made it easy on myself because I only have one variable in my data set, so I know I've got to click that over. But here's the other piece, the test value. The test value is the population mean. All right, so if you remember back to the previous lesson, we use a single sample t-test when we want to do what we're doing here. We have one sample and we want to compare it to a population value. Well, in this case, the population value is 12, and we do not know the population standard deviation. So that is unknown to us. So it's just kind of a question mark. Because of that, we cannot use the z-test, so we've moved over here to the one sample t-test. So what we need to do is type in the 12. That's our test value. That's our population value. If you click over here to options, you don't really have anything to change there. That is fine. And Bootstrap, we're not going to address right now. All right, and that's it. You say okay. And SPSS is going to give us all the information we need. So if I'm looking here, and I don't think it will let me, no, it's not going to let me write on here, but I can do this. I can go in here and type. Okay, so if I do my null, and I'm not going to, the null hypothesis is equal to mu, I'll just write it out, mu equals 12. So the null says that that the population mean number of obsessive compulsive thoughts is also equal to 12. All right. If I had an alternative, wait, hold on. I wanted you to stay down there. If I had an alternative hypothesis, I would say that it is not equal to H1. So mu is not equal to 12. All right, so that's my alternative. And I had to write it like this because I don't want to spend time trying to insert a mu and insert a equal sign with a line through it, so just kind of bear with me. But that, you get the gist. Here's the null hypothesis, here's the alternative hypothesis. So that's what's going on. I know now from SPSS that my one sample, size of 30, has a mean of 14.53 and a standard deviation of 2.2. So because we looked at the formula before, we know that this standard deviation is being used to estimate the standard error of the population, because we don't know the standard deviation of the population, do we? And so just like the formula showed, this is being inserted to get an estimated population standard error so that we can calculate t. So here is our test statistic right here. So we did not have to use a formula. It gave it to us, right? 6.282. So t equals 6.282. And this, from our little talk earlier, is t calculated. This is our t calculated. There's also a t critical that we talked about. Our alpha level, which I should have noted before we started, let me go back up here and drop that in. Our alpha level, or our critical value, alpha equals 0.05. I want to set that ahead of time and determine, okay, I'm looking for an obtained probability of less than 0.05. Okay, so now, like I was saying, using a computer program, whether it's SPSS or R or SAS or any of the data analysis software packages, we don't have to look in the back of the book anymore, or at any tables online or wherever else you might find them, because SPSS is giving us the obtained probability. So when we were talking before in the lesson on single sample t-test, I was telling you that the tables that we physically can look at do not give us an exact probability. What they do, they give us a t critical at a certain probability, such as 0.05, and then we can compare that to our t calculated. Okay, but using SPSS, we don't have to do that. What we want to look at is the obtained probability. So the probability of us having obtained the sample mean we obtained, if the null is true, is 0.000. And so I'm going to make a little note. This is the obtained probability. Oops, golly, can't type tonight. All right, hold on. There we go. This is the obtained probability. So, keeps kicking me back up. I like to have it separated because I think it's just a little bit easier to see, but not vital, of course. All right, so the probability of us having obtained the sample mean we obtained of 12, if the null is true, is really, really tiny. All right, so if we're going to compare P equals 0.000 to our alpha, which is P equals 0.05, to determine significance. Okay, now because we know that 0.000 is less than 0.05, so I'm going to say, I did it again. Okay, I'm not gonna worry about it. I'm just gonna, okay, this is not cooperating with me. Hold on, I'm gonna get it. There we go. Okay, so, hold on. Just love this. It's like a real class, isn't it? Where the professor keeps messing up. All right, so here we go. One more time. Our obtained probability is less than 0.05, or our cutoff value, or critical. So we have statistical significance. All right, we found statistical significance. So the population mean for people who've gone through this OCD treatment program is statistically significantly different from the general population mean of 12. All right, so it's comparing this estimation of the population mean with our test value, and it's finding, yeah, they are different. They're statistically significantly different. So like I was saying, for this scenario, that finding may not be the desired outcome or the preferred outcome, but who knows, it might. If this was our research and our data set, we would absolutely know. We would know what we were hoping for, and so on. But for this, we don't know. The last thing I want to show you about this output is how is it notated that you found significance. Because I think if you get in the habit of writing it now and knowing where the numbers come from, then it's just easier than trying to learn it later. So whenever you are writing this, in fact, I'm going to change this a little bit. Ooh, that looks weird. I wonder why I did that. I'm going to change this a little bit. I'm going to say, you see what it's doing? That's crazy. Okay, let me just skip over. Results of the one sample t-test are statistically significant. Can't. And then give yourself a little comma, and then these are the values you'll want to report, and this is what you'll see in journals or dissertations who use this type of t-test. All right, so we want to say t, and then in parentheses we're going to put our degrees of freedom. T at 29 degrees of freedom is equal to, and we're going to copy it down right down here from this table. Now, I always get the question of how many decimal places, and really I just go by APA because that's the format we use. Most of the journals that I read use APA. And APA says use either 2 or 3 decimal places, and they don't really care which, but they want you to be consistent. And so I'm just going to say 6.28. I'm going to drop off that. I'm going to round appropriately. I will say that if you're going to drop off decimal places, please round appropriately. 6.28. 28, comma. And here you can either say probability, P, and put the actual probability, 0.000, but you will see it written sometimes just as P is less than 0.05. And they won't include the actual probability, even though it is given to us here in this table. And you can notice here it's a two-tailed test, right? Just like we talked about before. But these are the values you'll want to use. And the reason we're doing that is for the reader. So instead of just saying, oh, our results were statistically significant, we're saying, yeah, they were. And reader, if you want to go and look it up for yourself, you can. T at 29 degrees of freedom was statistically significant. So they could go and look up T at 29 degrees of freedom at an alpha level of 0.05, figure out the T critical and compare it to our T calculated to make sure that we've come to the correct conclusion that it is statistically significant. Okay, so, and as you do these tests more and more and more, you're going to come to realize that any T that is this big, or Z or F or whatever test statistic we're using, any value that's this big is going to be statistically significant, most likely. I can't even think of a situation when it wouldn't be. Because if you think way back to earlier in the semester when we talked about areas under the normal curve and we drew the normal curve and we said, okay, a mean of 0, standard deviation of 1, and we did -3 to +3, and we said, hey, that captures 99.9% of all the responses. Well, what that means is that's almost 100%, right? At 3. So a value of 3 is going to be practically 0 here as far as probability goes. Now, if we were to instruct SPSS, it would carry, it's not actually 0, it would carry it out to, whatever decimal it really is. So it's not, like I said, that distribution is asymptotic. So we'll never get an actual 0, but it'll take it out as many decimals as needed. But anyway, what I was saying was anything beyond 3, a value of 3, is going to be teeny tiny, tiny, tiny. And so, and in fact, we knew exactly the Z value that you had to be greater than to get past the 0.05 level. Anyway, if that confused you, just ignore that. I'm just pointing it out. But do understand where these values came from, because you will need them if you're ever writing up the results of a single sample t-test. All right, I think that is it for this. I will talk to you in the next lesson.